Okay, so the question in the related to the thermal process, the first question, and there's a solar panel which is mounted on the roof of a house, figure 4.1, and it shows a section through part of the solar panel. Okay, so we are receiving sunlight from the upper part, and first we are having a glass sheet. So sunlight will strike first the glass sheets, then we are having some copper painted black pipe that is over here, and this one represents the water, and there is a air trap between the glass and these pipes, and in base we are having metal packing sheet painted black. It is also painted black, and some insulating material, so heat will not conduct on to the roof. It will only conducted by the pipes which are painted black. Okay, so this is the process, and we are using this sunlight to increase the temperature of water. A pump makes water flow through the copper wire. The wire is heated by passing through the solar panel. So the main purpose is to heat water. State and explain three features of the solar panel that maximize the final temperature of the water.
The copper pipe,
Okay, so copper pipe is a good conductor, so that is one feature. And what will be the other?
metal backing sheet,
Okay, so the first feature is that copper is a metal and also a good conductor of heat. Okay, so this is our first feature, and if we talk about the second one, so metal backing sheet is painted black, and also the copper pipe is painted black. So the reason for painting the black is that we know black is a good
it's a
absorber,
good
right? So it is also a good absorber and bad reflector.
yes.
So these are 2 points related to the solar panel that maximize the final temperature of the water. And last, we are using insulating material over here that will reduce the heat loss. So no heat will transfer onto the roof. So that insulating material help us to reduce the heat loss. No heat will conduct to the other part of the roof, right?
Yes.
So insulating material will help us to, or further we can write that glass produces greenhouse effect. So you may also write that greenhouse effect. So these are some features related to maximize the final temperature, right?
Yes.
Okay, in part B, during one day, 250 kg of water is pumped through the solar panel. The temperature of this water rises from 16 to 38 degrees Celsius. The water absorbs 25% of energy incident on solar panel. Specific heat capacity of water is 42. Calculate the energy incident on the solar panel during the daytime. So there is a temperature change. So temperature changes from 16 to 38. This will give you the value of change in temperature. This is the value of mass, and we are having a value of specific heat, and we have to find out the energy incident on the solar panel during daytime. So if we use the formula of specific heat capacity, so that will help you to find out the energy incident on the solar panel during daytime, right?
Yes.
So the formula for specific heat capacity, that amount of heat required to increase the temperature of 1 degree or unit mass to 1 degree Celsius or 1 degree Kelvin, right? You may write delta T or delta theta for the temperature. So all quantities will multiply on the left hand side. Cm delta T is equals to delta E. So you just need to multiply the quantities.
It's giving 23 million.
23 million.
Yes.
Okay. It means 2.3 into 10 to the power 7 joules, right?
Yes.
Okay. So this is the answer for the energy which we are receiving in daytime. And further, the solar panel in figure 4.1 is designed to heat water. A person is deciding whether to install solar panel or on her house. Okay, so let's suppose that we are have to decide either we have to install solar panel on our house or not. So list and explain three pieces of information she needs to consider in order to make her decision. So you already saw the setup, that how the solar panel works according to the diagram. So now we have to list down three features that helps her to consider either she wants to install the solar panel or not.
So she needs to check if the metal is a good conductor.
Okay. Okay, so that is already mentioned. The setup which we are following in the first part will be same. So we are using good conductor, that is copper. We need to check out the other factors also. So if we check out the other features, so let's suppose when we are going to install the solar panel, we have to check that in which direction the roof is facing, right? Because for solar panel, we have to face the sun. So first of all, the important feature is to check out the face of the roof, right?
Yes.
direction of the roof face to receive maximum thermal energy. So that is important. So basically, they are asking about three pieces of information, and question is of 4 mark. It means you have to explain in detail only one piece of information. Other you need to write the basic idea. And if we talk about the other feature, so the other feature is related to that what will be the output of solar panel, right? Because let's suppose if we want to install for the whole house setup, so we need to check out that what will be the output of the solar panel which we are using according to our requirement. So we need to find the estimated. In this question, you don't need to answer related to the convection or some scientific process. You need to answer with the normal daily life concepts related to the solar panel condition. So we need to find out the total estimated output of the panels, that either these panel or how many panels will help us to reach our required or desired output voltage. And further, if we talk about, so we also need to shade the roof, right? Otherwise, any hard material or any other material, just like in the diagram, we placed a glass over it so that solar panel is shaded, right? So the solar panel is completely covered. So we have to shade the roof. So we have to check either the roof is shaded or not. And the most important, the cost, right? What will be the cost of installing all these panels? So these are some factors. And further, you may also write that what will be the price or what will be the cost for the maintenance of that solar panel, because it also requires maintenance. So we need to check out the maintenance cost also. So you may also write that purpose. And the final part of this question, the sun releases energy as a result of nuclear fusion. State the meaning of nuclear fusion. So you just need to write the definition.
Nuclear fusion is when two or more than two smaller lighter nuclei fuse together.
Yes. So when two smaller nuclei combines to form a heavy nuclear, so that is the definition of the nuclear fusion. Okay, question 2, figure 4.1 shows a cross section of a double walled glass vacuum flask containing a hot liquid. The surface of the two glass walls of the flask have shiny silver coating. Why the rate of loss of thermal energy through the walls of the flask by conduction is very low? So,
Because it's trans reflectant.
okay. So we are using a silver surface. So that is silver surface mean, let's suppose if we are using a glass, so that is a poor conductor, or there is a gap between a silver surface or both silver surface because there is a gap between them. So this gap or this silver color reduce the loss of thermal energy by means of conduction process, right? So the vacuum gap will reduce the thermal energy loss and explain why the rate of loss of thermal energy through the walls of the flask by radiation is very low.
Is it because silver is a bad absorber?
Yes, so that is related to of silver color. We use silver color to overcome this thermal loss by the radiation process. So silver color or a silver is a good reflector and a bad absorber. So that's why silver color will help us to decrease the rate of loss of thermal energy through the walls, right? Okay, part B, suggest with reasons what must be added to the flask shown in figure 4.1 in order to keep the liquid hot. So if you consider the diagram, so this is the diagram. Now you need to answer what must we use to add it to the flask in order to keep the liquid hot.
A black coating?
Black coating, but black coat will provide you more amount of thermal heat. We have to add something which provide less heat loss over here or which keeps the liquid hot for a long time. So there is something missing in the flask. So
The lid?
yes, so lid or stopper is missing in the diagram. So heat will loss very quickly to the atmosphere. So the answer for this is we need to add a stopper or a lid on the top of the flask to reduce the heat loss by convection and radiation. So this is the reason this is the component which we need to add in the diagram to reduce the heat loss by method of convection and radiation, right?
Yes.
Okay, question 3. One side of a copper sheet is highly polished and the other side is painted matte black. The copper sheet is very hot and placed in a vertical position as shown in figure 5.1. A student places her hand at equal distance from the sheet as in figure 5.1. Explain why her hands are not heated by convection.
Because convection only occurs in liquids.
But it also happens in gases because it happens for fluid, so gas and liquid both will flow. So it will happen in air also, but there must be some different reason. If you remember the concept of that heater or that sea breeze and land breeze that we discussed, that heat will always move in which direction?
Top.
Yes, so heat will move in the upper direction or towards the top. So that is the reason that their hand is not heated by the convection method. So hot air or warm air will always flow in upper direction. So hot air will move in upper direction. That is the reason her hands are not heated by convection. And why her hands are not heated by conduction?
No direct contact.
Yes, no direct contact. There is a gap between hands and the plates. So there is a gap between hands and plates, so there will be no direct contact. So that is the reason. And state and explain which hands gets hotter. First, you need to identify which hand will get hotter, and then you find out the reason also.
Is it the left hand?
Okay, left hand. And what will be the reason?
Because of the black side.
Because of the matte black side. So a left hand will get hotter as compared to the right. And the reason is that left hand is facing matte black side. Matte black side is a good absorber and emitter, right? So that is the reason. And it is suggested that one side of the copper sheet cools to a lower temperature than the other side. Explain why this does not happen. One side of the copper sheet cools to a lower temperature than the other side. Explain why this does not happen. Okay, so they are talking about the process. We are having two sheets, copper on the right and matte black side on the left. So they are asking that copper is a conductor, and we know that if the temperature of a good conductor will increase quickly, so the temperature will also fall very quickly, right? So they are asking why the temperature of this copper will not fall quickly. What is the reason? Because it is in a contact with a matte black side. So basically, it will start transferring heat from copper side to the matte black side because it is the conductor. So the purpose of conductor is to conduct heat. So the temperature or the final temperature of copper will not fall quickly because it starts conducting heat from matte black side, because matte black side is a good absorber, and it is also a good emitter. So the heat absorbed by the matte black side will stay for long time as compared to the copper. So if the temperature of the copper starts falling, so heat will be conducted from the left hand side, that is from the matte black side. So that's why the temperature of the copper will not cool down because of the conduction process through the matte black side. Okay.
Yes.
So copper continuously conducts heat from the left hand side. So that is the reason. So copper conduct heat from left side because copper is a good conductor so heat will transfer quickly to it, right?
Yes.
Okay, question 4.
Can AB lose more thermal energy?
Okay, the cans are heated. Predict and explain the relative rates of loss of thermal energy by infrared radiations from the two cans. So which can will lose heat more quickly, A or B?
A?
A will lose heat very quickly.
No, B.
B, so A is the polish, so it normally reflects the thermal energy or the heat waves, and B is a dull black surface, so it absorbs thermal energy very quickly and it also reflects thermal or emit thermal energy very quickly. So in the answer, we can write it as can B lose thermal energy quickly because black is a good emitter or radiator, right?
Yes.
And part B, a student is provided with two canes, a supply of hot water, and two thermometer. Describe the experiment he should carry out to test your answer to A. So we have to explain the whole experiment. We are having different apparatus. We are having two canes, a supply of hot water, and two thermometers. So we need to describe the whole experiment. So experiment, you have to write the whole step by the sequence. So first of all, we have to pour hot water in both containers with at same level, right? So we have to fill the both canes at same level with hot water. So now equal amount of thermal energy is going to be provided by the to the canes, right? To the polished side and to the black side. Then what will be the next step?
We measure the temperature using the thermometer.
Yes, and measure the initial temperature with the help of thermometer. Okay, what will be the next?
We measure the time using a stopwatch.
Okay, but we are not having a stopwatch in our apparatus. And the next important thing is that thermometer will not touch the walls of the cane, right? Otherwise, it will also record the temperature of that body. So it depends upon the conduction or the other process. So we have to check that thermometer not touching the walls of the cane. And after some time, we have to record the change also, right? Because we are not having a stopwatch, otherwise we will record according to the equal time. But after some time, just roughly estimate, we again record the temperature, so that will give us the change in temperature, that which cane is now at low temperature and which cane is at high temperature. So the cane with low temperature means that it radiates energy very quickly, so that's why temperature will decrease, right? So next we have to observe the change of temperature. And then we have to repeat the process for some time. Repeat the process for some intervals, because we always record more than one values, then we will find the average value, so there will be less chances of error in the experiment, right?
Yes.
And another student is given the same equipment but find two polystyrene tiles. 5.2 as shown in figure 5.2 shows the tiles alongside the cane. State how she could use the tiles to improve the experiment and explain why this effective. So in previous example, we are not having the cover or the lid, so thermal energy will lose quickly. So now if we place these tiles over cane A and B, so it will reduce the thermal energy loss, right? So one
Yes.
process is that we have to place these polystyrene tiles over these cane, so that will reduce the thermal energy loss. And the second is that we can also place it in the bottom, so that will also reduce the thermal energy heat loss by the conduction process with the ground. So both are the possibilities, right?
Yes.
And the final part, the two canes are now filled with cold water and placed equal distance from a strong source of infrared radiation. State and explain which cane of water heats up more quickly.
The black one?
The black one, because now we are having radiations and radiations can be absorbed by the black one, so this will absorb more quickly. And we know the reason that black is a good absorber and a good emitter, so cane B will absorb radiation more quickly as compared to the cane A, right?
Yes.
Okay, so these are some questions which is related to the thermal process. I hope that is also not much very difficult.
No, it's not.
Okay, so try to solve the remaining MCQs and the detailed question, because most of the
Okay.
questions are related to the same, they are asking the same concept, that which is the good conductor, which will be the bad, about the colors. So concepts are not much very difficult. Okay, there are some misprinting between 2 or 3 pages. Okay, so try to solve the remaining part and let me know if anything will be difficult. So we will discuss in the other class, and that question is repeated, but questions are different. Experiment was same.
Yes.
Okay, then tomorrow we will start our space physics section, right?